student, we will take one example to explain the gram atoms, gram molecules, moles and entities. So it is given that in 0.2 mole of CD4, find the number of molecules of CD4. So it is to be noted that we have to calculate the number of molecules which is entity. It is to be noted that the number of molecules will be equal to N into Na, and directly we have been provided the number of moles, so 0.2 into Na will be the answer. Now it is to be calculated the number of moles of carbon. So obviously number of moles of carbon, or they can ask the gram atoms of carbon. So we should be careful that 1 mole of CD4, we should always deal for the 1 mole. So 1 mole of CD4 contains 1 mole of carbon. So 0.2 moles of CD4 contains definitely 0.2 moles of carbon, 0.2 moles of carbon, or we can use gram atoms for this also. It is to be noted that gram atoms is moles. Now it is to calculate the number of moles of deuterium. So definitely 1 mole of CD4 contains 4 moles of deuterium. So 0.4 contains 4 into 0.2, that will give 0.8 moles of deuterium. Here 0.8 moles of deuterium, or we can say this, these are gram atoms of deuterium. Now number of moles of electron, to be noted that the number of moles of electron is entity. So सबसे पहले हम इसमें number of electrons calculate करें. This will be equal to 0.2 into Na into 10. Obviously the CD4 contains 6 plus 4 electrons, so the number of electrons is multiplied by this. So this will be equal to 2 Na, but the 2 Na is the number of electron, and in the question it has been given that number of moles of electron, so the correct answer will be 2. It is to be noted that, I am repeating, it has been asked in the question that moles of electron is to be calculated. So the moles of electron will be equal to 2, but the number of electrons will be equal to 2 Na. The number of moles of proton, in the same way we can calculate, it will be definitely 2. The number of moles of proton will be 2, but the number of protons, if it is required to calculate, then definitely it will be 2 Na, because the number of entities involved, the Avogadro's number Na. Now number of moles of neutrons is to be calculated. So in the CD4 we can calculate the number of neutrons as 0.2 into Na. Now into number of neutrons is to be calculated, then definitely it will be 10. Again this will give 2 Na, which will be equal to 2 moles of neutron. 2 Na is the number of neutrons and 2 is moles of neutrons. It is to be careful that neutrons, how we can calculate the number of neutrons, that 0.2 into Na into 10 in the CD4, because this is deuterium which is 1H2, and deuterium contains 2 minus 1 which is 1 neutron basically. So now it is required to calculate the mass of carbon in this 0.2 moles of CD4. Moles of carbon is 0.2, so we can multiply by this 12, which is the gram atomic mass. So you will get 2.4 gram. And the mass of deuterium, in the same way we can calculate 0.8 into 2. Now we can calculate mass of D2 in the same way, and the mass of CD4, that will be equal to 0.2 moles. And the CD4 का अगर हम ग्राम मोलिकुलर मास निकालेंगे तो definitely carbon will be 12 and deuterium will be 4 into 2, which will be 8. That this will be equal to 12 plus 8, that will be 20. So we will get the 4 gram. Now one more question is to be discussed, that find the ratio of number of neutrons present in 4 gram of each H2 and D2O. So the number of neutrons is very obviously it is entity. So we can equate that number of neutrons in H2O, that will be equal to 4 divided by the molecular mass of water into Na. Now we can calculate the number of neutrons in water, that hydrogen does not contain any neutron, so it will be multiplied by 8. So the total number of neutrons in H2O will be 8. So the number of neutrons in H2 will be 4 by 18, which is moles into Avogadro's number into number of neutrons, and the number of neutrons in D2O, that will be equal to, because the 4 gram is given for each, and the mass of D2O, definitely molecular mass of D2O, that will be 20 into Na into, if we will calculate the number of neutrons in D2O, then how many neutrons will be present? Definitely deuterium is 1H2, so 2 plus 8, because D2O ko we can write as 1H1 1H2 whole twice O8 16. So 16 minus 8 will be 8, and 2 minus 1 into 2, that will be 2. So 2 plus 8 will be equal to 10. So the number of neutrons will be equal to 10. So we can divide this equation by this, then definitely you will get the ratio 8:9. So these are the some of the problems which is based on the number of entities and methods to calculate number of moles. We will take more example to explain this concept. Thank you very much.